Good morning, my name is Leonel Garcia. The project in the about topic very things the true jitter performance of clock high speed digital digging. Your task measuring for clock in heat speed digital desing has become increasing challenging plans. For example, introduce data right of hot to a week occurring in the weeks 18 for minutes in aiming effects technology. And used and HDMI, typical whose spirit and clock science books addition strict clock how the genes also next be verified and the unmodded.
Hello, my name is Timothy Troney. I'm here with the TI's Clock and Timing Group. I'm here to talk to you about using the LMK48 2X device in JEDEC applications, specifically JESD204B. To demonstrate, I have a 4828 eval board here. I have a 122.88 megahertz reference going into the 4828 IC. I have power for the device. I have the clock outputs connected to the oscilloscope for measurement, and I also have the programming cable hooked up through the USB to any. This programming cable is connected to the laptop, which I will use with the CodeLoader software to manipulate the timing waveforms. The 4828 has many different features. One VCO cycle forward, and now this setup time from sysref to device clock edge, as shown in the measurement below, is about 600 picoseconds. This is actually very good and gives us margin on the 400 picosecond required setup time and is out of the 100 picosecond hold time. If I were to adjust this forward one more VCO cycle, we would
Time in solution. Measuring clock jitter typical consists of measuring the bass noise with the bass noise visit and the current and system transforming fusion integrating the waves bass noise in the definite enduring integration range. Integrating the weight and pace noise. The weight pace noise is typically integrated to the night frequency of the clock, halt of the race, and insane case even that case the pace noise also needs to the measuring of the higher frequency offset.
Hello and welcome to the TI Precision Lab discussing clock jitter considerations for high-speed data converters. In this video we'll discuss what jitter is, where it comes from, and how it impacts the noise performance of a high-speed data converter. We'll also look at how to calculate jitter and steps to minimize. The jitter of the external clock signal can be calculated by integrating its phase noise. For that calculation, one has to set the upper and the lower integration limits. The lower integration limit is typically set by the application. If the application uses FFT processing, for example, then the lower limit is set by the FFT bin size, as shown in the figure on the left. If it's a telecom application, the lower limit is set by the channel spacing. In GSM communications, for example, the channel spacing is 200 kHz. Any phase noise closer in than that is not relevant. The right figure shows that the lower integration limit. During the sampling process, the clock signal phase noise gets added to the input signal. But the clock phase noise amplitude also gets scaled by a factor of 20 log input frequency to clock frequency. Similar as in the time domain analysis, this makes it harder and harder to detect small wanted signals. So what can be done to minimize the clock noise impact to the SNR?
Measuring Measuring the base noise. For clock with a high sleep rate, the clock jitter is mainly determined by the base noise of the clock. Since again noise is greatly surprised by the high sleep rate of the clock, it typically does not contribute to the overall clock. Jitter for accurate clock heater measurements, high again. Suppression in the base noise measuring is important. Thank you. My name is Leonel Garcia, student in English technique number 2. My teacher is John Moscoso, and from in the Guayaquil City.